To graph the cosine function y equals cosine x, we will once again put in angles 0. So 0 as an x value, so we get y equals cosine of 0. Remember that the cosine values are the x values of the points on our unit circle. So the first coordinates. So the cosine value of 0 is 1. The cosine value of pi over 2 is 0. Cosine value of pi is minus 1. The cosine value of 3 pi over 2 is 0. And back to 2 pi, our cosine value is 1 again. Now as we go through, we'll repeat the same values. So 5 pi over 2, if I go around the circle again, we get an x value, or our cosine value of 0. 3 pi over 2, picking off the x value of that coordinate, we get minus 1 for our cosine value. 7 pi over 2, we get a cosine value of 0. And back to 4 pi, we get a cosine value of 1. So we see that the cosine values start to repeat themselves. Now we want to plot these points, 0, 1, pi over 2, 0. So we're going to plot points on our x-axis, which represents our angles and radians, and our y values will represent our cosine values. So here's our angles in radians. It's our x-axis. And this will represent our cosine values. So we're going to plot our points. We have 0, 1, pi over 2, 0. And at pi, we're down to minus 1. 3 pi over 2 has a cosine value of 0. And 2 pi, we're back at positive 1. So once again, we see that cosine has a period of 2 pi. So we complete one full cycle of cosine between 0 and 2 pi. And if we keep going, 5 pi over 2 gets us back to 0. 3 pi is a cosine value of minus 1. 7 pi over 2, we're back to 0. And at 4 pi, we come back up to positive 1. So this pattern continues every 2 pi units in both directions. So we want to remember this basic shape of cosine. Cosine starts at its maximum and then comes back down to the x-axis for its x-intercept. And then it goes down to the minimum of minus 1. At 3 pi over 2, it comes back to the x-axis, so here's its x-intercept. And then at 2 pi, it's back to the max. So we want to remember this basic shape that will represent cosine. Once again, recognize that we are broken up into 4 equal segments, each one representing a quadrant. And in quadrant 1, cosine is positive. Quadrant 2, cosine is negative. Quadrant 3, cosine is negative. And then quadrant 4, cosine is positive again. So for y equals cosine of x, here's our basic shape. We want to remember that pattern. The domain, since our graph goes forever in both directions, we have a domain of all real numbers all the way from left to right, so all x values get used. The range, our y values, go from minus 1 all the way to positive 1. The period is 2 pi. Remember that it takes 2 pi units for me to complete one cycle of cosine. The amplitude, remember that's the distance from the middle of the graph to the top of the graph, from the middle of the graph to the bottom of the graph. We have an amplitude of 1. So we have 1 unit is the distance from the middle to the top and from the middle to the bottom. The graph is symmetric with respect to the y-axis, so we would say that this cosine function is even. And what that basically means is that if we have a negative on the input of our function, that is the same thing as having a positive value on the input of our function. So we could say cosine of, let's say, pi. So let's say negative pi. So cosine of a negative pi would be equal to the same thing as cosine of positive pi. And in fact, cosine of negative pi would be -1. Cosine of positive pi would also be -1. So we would say this is an even function. If the negative on the input is the same as the positive on the same number but opposite signs, we get exactly the same cosine values.